Hi dears, welcome to my channel. Today we are discussing the 11th chapter of class 10, that is electricity. What is electricity? How the electricity works, and what is resistor, what is current, what is charge, voltage, everything we have to learn in this chapter. And moreover, various numerical problems also will be asked. So it's very important chapter. We are going to see what it is. Before that, we have to discuss the 10th lesson, Human Eye and Colorful World. There I have asked you 3 questions. It's the time to answer. First question was, to rectify hypermetropia, we should wear dash lens. Which lens, ma? It is convex lens. Second one, brilliance of the diamond is due to dash. How the diamond is getting that much shine? It is because of total internal reflection. And the third one, when we donate our eyes, which part of the eye is taken after death? After our death, if we are donating eye, which part is taken? It is cornea. Okay. Now we are moving to see the 11th chapter. What is that? Electricity. The important terms which we are discussing in part A are electricity, what is charge, what is current, potential difference, electric circuits, series and parallel, Ohm's law, then resistance, resistivity, and comparison with resistors having parallel connection and series connection, and advantage of the parallel connection. Okay. Shall we go quickly to the chapter? Okay. Electricity. What do you understand by the term electricity? Electricity is also a source of energy. And how the source of energy is forming? Do you know? It is because of the movement of the particles which are having charge. By the motion of the charged particle, electricity is generated. This electricity is used in various fields. Almost all the fields, electricity is used more than any other source of energy. Why? Why is it so? Because of the specialities of electricity. Because the electricity is, the first point and important point is, the electricity is the convenient source of energy. Second one, it can be transmitted but to a larger distance with very less loss. Okay. And the third and important point is, it can be changed from the electrical form to any other form very quickly. That is the forms like heat or light or sound or motion. That is any other form, it can be changed easily. That's why electricity is used in various fields like industries, in household works, in agricultural field, and in many other fields. Okay. As we have seen that electricity is produced only by the motion of particles with charges, we should know what is charge. It is the property of the matter which makes it or causes it to experience a force when it is kept in electromagnetic field. If the matter is kept in electromagnetic field, a force it is experiencing, which is what it is called a charge. Okay, charges are of two types, positive charge and negative charge. When we are saying about the negative charge, electrons are coming in our mind, isn't it? Electrons are having charge. We have learned in the 9th standard itself. What is the charge of electron? It is minus 1.67 into 10 raised to minus 19 coulomb is the charge of electron, while the proton is having positive charge, that is plus 1.6 into 10 raised to minus 19 coulomb, isn't it? So when the electrons are moving, the charge will be generated. What is the unit of the charge? Unit of charge is coulomb. 1 coulomb is equal to number of electrons into charge of electrons. Okay, what is the charge of electron? We have already said it is minus 1.6 into 10 raised to minus 19. See. So, a question for you. Can you find the number of electrons when 1 coulomb of charge is transmitted? When 1 coulomb charge is there in a particle, what will be the number of electrons in it? How can you calculate? 1 coulomb is equal to number of electron into charge of electron. We already know the charge of electron. And here, this is 1 is equal to. Therefore, N is equal to 1 divided by 1.6 into 10 raised to minus 19. See. So, what will be the answer? When you are doing, you will get the answer as 6.25 into 10 raised to 18. That is 6.25 into 10 raised to 18 is the number of electrons. This much electrons will be present which are having the charge of minus 1.6 into 10 raised to 19 for making 1 coulomb of charge. Okay. This much electrons are present. Now, we should know when the electricity has to be occurred, this charged particle has to be in motion. in which substances these charged particles are allowed to move and which substance will not allow the charged particles to move and which substance will partially allow these charged particles to move, we should learn. That is, types of substances. The substances are divided into three types. What are they? Conductors, insulators and semiconductors. What do the conductors do? It fully allows the charged particles to move through it. Allows the electrons to pass through. So what happens? Electricity can be produced in conductors. Okay. Then insulators. Insulators are the one which does not allow the electrons to move through it. So electricity is not allowed to pass through these insulators. Okay. Then semiconductors are the one which allows the charged particles to move through it partially. So they are called semiconductors. Okay, ma? So conductors, insulators and semiconductors. We are learning. Electricity can be of two types. What are they? Static electricity and current electricity. Static, what do you mean by that? Static means it will be stationary. It will be at rest. Charged particles will be produced, but these charged particles are not allowed to move. It is called what, ma? It is the static electricity. Is there any example? Yes, examples are there. This is an experiment also. When you are rubbing your scale on a dry cloth for a little time, after that, when you are allowing it to go near the pieces of paper, we can see these pieces of paper quickly jumping to the scale. Have you seen? This is because of the static electricity. The charged particles are there, but these charged particles are not allowed to move easily. The accumulation of charge is there at a particular surface. Here in the scale, the charge will be present, but it will be accumulated to a large extent. For that, the papers will be attracted and it is jumping over it. Okay. So this is static electricity. Now, the second one, that is current electricity. Current electricity means what? The charged particles are there and the charged particles are allowed to move. So this is what, ma? It is the current electricity. What is current? Current is the rate of flow of charged particles per unit time. When it is the charged particles are allowed to move through a conductor. It is called what, ma? It is current. Okay. So what is the relation with current and charge? Yes, current is having relation with charge and the relation is, what is the symbol of current? It is I. I is equal to Q divided by T. Q by T is the relation. When charged are allowed to pass and when it is measured per time, we will get what, ma? Current. What is the unit of current? Unit of current is ampere. That is an important question which frequently used to ask. That is, what is 1 ampere current? Current is said to be 1 ampere if 1 coulomb of charge is allowed to pass through a conductor in 1 second. So can you define coulomb based on the current? You know, I is equal to what, ma? Q by T, isn't it? So what will be Q? Q is equal to IT, isn't it? So the unit of charge is coulomb. So what will be 1 coulomb? 1 coulomb is the amount of charge passed through the conductor in 1 second when the current is 1 ampere. Okay? The amount of charge which is passed through the conductor in 1 second when the current is 1 ampere. Now, how can we measure the current? There is a meter for measuring current and that meter is called ammeter. Usually current is a scalar quantity and this current can be measured. As we know, the unit of current is ampere. Ampere will be, this will be usually in the form of milliampere or microampere, like that. Milliampere means what? 10 raised to minus 3 ampere. Microampere means what, not 10 raised to minus 6 ampere. Okay, then about it is, current can be measured by using what? By using an instrument called ammeter. Ammeter will be having, the things which you have to know about ammeter is, ammeter has to be connected in series with the circuit, and the second one is, it will be having low resistance. Okay, so all these, what is that resistance and what is about the series connection, all this we will learn when we are moving forward in this chapter. Okay, now we are moving to see potential difference. So how the current is moving? If there is a potential difference, then only the current will be moving, isn't it? Even though in the case of water, if 2 tanks are there and there is a connection between these 2 tanks, and if the water level in these 2 tanks are filled, will the water flow from one tank to another? No. But if one tank is having more water than the other tank, and if there is a connection at the down part, the water starts to move from the level, higher level to the lower level. Like that, potential has to be maintained. Potential difference has to be maintained. If the potential difference is there, what happens? The charged particles will start to move. Who is making this potential difference? It is done with the help of batteries. So batteries in all the equipments which we are carrying. Small equipments, batteries are there. What is the battery doing? It will be having positive terminal in one part and the negative terminal in another part. So the negative terminal will be having more electrons, while the positive terminal will be having the loss of electron, will be not having electrons more. So what happens? The electron starts to move from the negative terminal to the positive terminal. What is the electron having? The electrons are having charge and it starts to move. So what happens? If the movement is there, the charged particles, as the charged particles are moving, the current will be generating. Okay, so the potential difference is very important. So what is the potential difference? What do you mean by that? It is actually the work done in carrying the charged particle from one part to the another. Okay, so work done divided by charge will give you what, ma? Potential difference. Okay, what is the unit of this potential difference? It is volt. So can you explain what is 1 volt? 1 volt is defined as the 1 joule of work done in carrying the charge of 1 coulomb. If 1 joule of work is done in carrying the charge of 1 coulomb, we can say the potential difference is 1 volt. Okay, so is there anything to measure this potential difference? Yes, voltmeter is the one to measure the potential difference. There we have seen for the current to measure, ammeter was there. Here voltmeter is there. There we have seen ammeter has to be connected in series. Here voltmeter has to be connected in parallel. Ammeter, there we have seen that ammeter is having low resistance, but here the voltmeter will be having high resistance. For checking the voltage, voltmeter is used. For checking the current, ammeter is used. Okay, so what is this parallel and series connection? We will learn. Electrical circuit is a closed pathway through which the electrical current flows, isn't it? That is the electrical circuit. It's a closed pathway in which electrical current is flowing. Is a connecting wire made of conductor or insulator or semiconductor? It should be made of conductor. Then only it will allow the electrons to pass through. Then only the electrical circuit will be having the charged particle movement all the time. Circuit can be easily represented by using diagram. Diagram is a graphical representation of it. It will be having what, ma? Symbols more. I am drawing a electrical circuit. The things which are seen as, this is battery, isn't it? This is the plug. If there is a point here, which means that the circuit is closed. It's very important. If there is a point inside, it means the closed circuit, that is the switch is in on position. Okay, then this is the resistor. Voltage is connected in this manner and the ammeter is the one which for measuring current. Okay, we have already learned the voltmeter should be connected in parallel while the ammeter is here for checking the current, which is connected in series. So we should learn what is series connection and what is parallel connection. Consider 3 bulbs. 3 bulbs are to be connected in the circuit. Okay, so if we are connecting in this manner, now this is the connection. This is the series connection. Here, what are the specialities, ma? In the series connection, the equipments are connected in the linear fashion. Here, secondly, we can say the current remains constant. Current remains constant in these bulbs. And thirdly, voltage differs in this case. Okay, it is not conveniently used. More probably, it is not used in home appliances and all. So this is what, ma? This is the series connection. Now we can see the parallel connection. What will be the parallel connection? It means what? It is having multiple pathways. The parallel connection will be having multiple pathways. Here the voltage remains same, but the current will be varying. This will be having varying current and constant voltage. Okay, this is much more reliable way of connection. Okay, in households many appliances are there, isn't it? They're all the parallel connection is the one which is given. Okay, so these are the difference between series connection and parallel connection. Ohm's law is the one which found the relationship between the potential difference and the current. the potential difference will be increasing if the current is increasing, which means potential difference is directly proportional to the current. So what is the Ohm's law states? Ohm's law states that the potential difference across the metal or a conductor is directly proportional to the current passing through it. Okay, this is Ohm's law. So we can say V is directly proportional to I, or V is equal to IR. What is R over here? R is the resistance. How can we relate it graphically? We can relate in this manner. When voltage is in y-axis and current is in x-axis, we will get a slope, and the slope shows resistance. If the slope is more and more, which means that resistance is more and more. If the slope is much less, we can say resistance is very less for this material. Okay. Now, what is resistance? We will learn. Now we are moving to see about the resistance. From the Ohm's law, we have found one thing, that is potential difference or voltage is directly proportional to current, or V is equal to IR, where R is resistance. So what is resistance actually? Resistance is the property of the substance to resist the flow of charged particles through it. It can be conductor, or it can be insulator, or it can be semiconductor. But normally we say about the conductors because only in the conductors the electrons are free to move, isn't it? So the property of the conductor to resist the flow of charged particle or to resist the flow of current is called what, ma? It is the resistance. So if the conducting substance is there, resistance will be surely felt for it. What are things the resistance depends on? The resistance depends on the length of the substance and also the area of cross section. If the length of the substance is more, which means the charged particles or the electrons has to move more distance, isn't it? If the length is more, much more distance it has to travel. So if the electrons are traveling to more distance, what happens? Collision may happen between these electrons. So what happens? The flow of current will be disturbed. Means the flow will be a little less, isn't it? This is what? Resistance. So the flow of the current can be controlled by what, ma? By this resistance. Okay, so as the length is increased, resistance also gets increased. What happens? So we can say R is directly proportional to L. Okay, second one. What happens if the area is increased? If the area of the conducting substance is increased, it means without getting collided, the electrons can pass freely. Okay, so what happens? Resistance will increase or decrease? Resistance will decrease. So R is directly proportional to 1 by A. That is, R is inversely proportional to A, or in other words, we can say R is directly proportional to 1 by A. So we can conclude what is R. R is equal to, R is proportional to L by A. So R is equal to what, ma? Rho L by A, where rho is a constant and we are saying it as resistivity. Okay, now we have seen resistance depends on the length of the substance and also the area of cross section. Is there any other thing which resistance depends on? Yes, resistance is depending on the nature of substance. There are some substances in which are having low resistance. For example, silver. It is having very less resistance. So, that's why silver is considered to be the best conductor. Okay. There are yet another substance which are having high resistance. Even though they are conductors, resistivity or resistance will be high. For example, iron. For iron particles, the resistance is much more. So, they are not the good conductors. Okay. What is the SI unit of resistance? Who invented resistance? Ohm. So, SI unit is what, ma? Ohm. Resistance OHM. Okay, this is what. And we have found the relation R is equal to rho L by A. Can you find what is rho from this? Yes, we can find what is rho. Rho is equal to what, ma? R A by L. What is R? SI unit of R is ohm. Area is meter square. By L is meter. So what is that? Resistivity is having the unit ohm meter. Okay, what is the resistivity unit? Ohm meter. Range of resistivity varies with substances. In the case of metals and alloys, they will be having very less resistivity. It ranges from 10 raised to minus 8 to 10 raised to minus 10. So resistivity is very less for what? Alloys and metals. Whereas for non-metals or non-conductors like rubber, plastic and all, the resistivity is very high. What is the resistivity? It ranges up to 10 raised to 12 to 10 raised to 17. Okay, in that manner, the resistivity for non-conducting substances, and for conductors it will be very less. Okay, so from that we can understand which is the best conductor, which is the good conductor, which is the bad conductor. All these we can understand by knowing the resistivity. Okay, so almost in all appliances, when it is connected to the circuit, electrical circuit, resistance is put. Why the resistance is that much? Is the resistance that much important? Yes. Resistance is very important. In all the appliances, resistance is put. Because if the resistance is there, it will cut off the current or it will control the current. The current flow can be controlled with the help of a resistance. So, the resistance will be surely put for every appliance. Okay. If we are not able to control the current flow, what happens? The electrical appliance will be damaged because of high current or high voltage. So if the resistance is there, it will be cut off. This current will be much more controlled. For that purpose, the resistance will be put. Now we are going to see how the resistance has to be put. If the resistance can be put in series manner or if the resistance can be put in parallel manner, we are going to see. For that we have to see resistance in series and resistance in parallel. So how it will be when the resistance is put in series manner? Series manner means what? End-to-end connection. If two or more resistors are put, the resistors are to be connected in the end-to-end manner in the series form. See, this is the connection in which three resistors are there to say R1, R2, R3. This R1, R2 and R3 are connected in what? In series form. That is end-to-end connection is given. Let's see how the resistance is varying. We know in the series connection, current will be constant while the voltage will be varying, isn't it? Current will be remaining constant. So how can it be represented? V is equal to IR. Here I is constant. V1 is equal to IR1. V2 is equal to IR2. And V3 is equal to what, ma? IR3, isn't it? So we can take I is constant in every case. So total V is equal to V1 plus V2 plus V3 is equal to what, ma? I R1 plus R2 plus R3. In this manner it will be. So R is what, ma? R1 plus R2 plus R3. We are understanding that the total resistance is equal to sum of the individual resistances. Okay. The sum of individual resistance give you the total resistance. What is the speciality of it? In the series connection, current remains constant, but the voltage will be fluctuating. It is not an appropriate way for connecting all the appliances by this manner, because if one resistance is broken down, the full circuit, the current will be stopped. Then we are going to see the resistor when it is connected in parallel. Here, this is the parallel connection. In this parallel connection, three resistors to say R1, R2 and R3 are there. They are connected in the parallel manner. What is the speciality of the connection when it is done in parallel manner? Here, the voltage remains same, but the current will be varying. The similar equation V is equal to IR. But here, current is varying, but the voltage remains same. So we are finding I. What is I, ma? I is equal to V by R, isn't it? I1 is equal to what, ma? V by R1. I2 is equal to V by R2. And I3 is equal to V by R3. So total I is equal to what, ma? I1 plus I2 plus I3. So what? It is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. In this case, in the case of parallel connection, what will be the total resistance? Total resistance is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Reciprocal of individual resistances will give you the total resistance. So what happens? Total resistance will be less in the case of parallel connection than that of in the series connection. So what happens? This is the best way. While we are connecting electrical appliances with the same current, what happens? This parallel connection is the better way. So what is the difference between the series connection and parallel connection? In the case of series connection, as the current is a constant and the voltage is fluctuating, if any of the electrical appliances stops working, it will affect the entire circuit and the entire circuit will be blocked. But in the case of parallel connection, the current is individually passed through it, isn't it? So even if one resistor or one appliance or anything is not working, the others will be working. Because so parallel connection is the best way. It's used in household appliances, and the series connection is used for the holiday lights and all. Part A is completed here. We can see the rest of the class in part B.